Oh, I'm starting the stream.
Okay.
Tell me if it's... Maybe you messed it up. I don't know.
Now we can see it. Perfect.
What did I do?
So I think it's good. So I will start sharing the screen if that's all right.
Just give me a second. Okay. Yeah, do whatever you have to do.
Perfect. Good. One moment.
Participants.
So I'm going to mute everybody, or can you mute everybody, Michael? Except me.
Just give me a second.
Sure.
Yeah. Participants.
So, hello everyone. Welcome to the latest and greatest session of our user group, Zurich Dev, also called Zurich Developers.NET User Group. First, I want to give a special thanks to our sponsors offering solutions, ViviVow, for Texture, Impact Hub, and the Stanford Group. And a special thank you for our partners in crime, the Azure User Group and the Loser and Burn.NET User Groups. Also, .NET Switzerland and Swiss Angular. Thank you very much. Who are we? Well, you can see these 7 people in the screen, and below them there are our Twitter handles where you can quickly contact us. Today, it's Michael and me. What do? We organize events from developers to share knowledge and passion in order to create excitement about technology, and networking included, and usually beer and pizza, but usually not online. That said, we will have a drink and mingle later on. So we will do the event and then we will stop the streaming. And at one moment, whoops, sorry. We will take our favorite drink, can be tea, can be water, can be a beer. So please stay until the end. It's fun. And usually our speakers stay and we can have very interesting conversations. Also, you can follow us on Twitter, .NET Zurich, in also LinkedIn. Join our meetup group, which probably you have. Tell your peers, help us grow, and propose new content and the speakers. And that's it. Michael, I give it to you.
Yeah, today we will listen to Irina, and she's a great speaker. I met her a while back in Kiev, and since then we had still kept on chatting. And she will talk about gRPC. I know a lot of you guys are really keen on that. And with that, let's hand it over to Irina. You should be able to unmute. Yeah, your co-host.
And I also need to share my screen, right?
Yes, you can just do it. Jose, can you stop sharing?
Yes, one more thing. Oh, no, it's too late. Okay. You had slide 9, but you can show it at the end. Or Irina, can I interrupt you a bit more?
Yeah.
Sorry. Can you see the screen? Screen 2. So the agenda for today is we will finish this introduction, we will go to the session, and then conclusion and explain a bit the next event, which is not really ours, but it's also ours, right, Michael? And then do the mix and mingle.
Okay, then I'm so sorry because I came in late. I was not prepared.
Yeah, no worries. So there's a special announcement. We have a really, really interesting event, which is happening tomorrow.
Yeah, tomorrow we have launched Hot Chocolate Server 11, our GraphQL server, which is now one of the fastest GraphQL server out there. There's really nothing else that is on par with it at this point. So join us and we will have a great launch event where we have a couple of speakers, not just me. there will be all the contributors who show their piece that they built in version 11. So join us and have some fun, and make sure to bring drinks. But with that, let's give it to Irina.
Wait one more second. If you have questions, please write them on the Slido chat. I will share it now on the team meeting, the Zoom meeting chat. Okay, and Irina will respond to them at the end. Irina, it's your stage now.
Are you sure?
Yes.
Once again, are you sure?
Maybe.
We'll see. Too late now. Well, thank you for having me. First of all, thank you, Michael, for the invite. I apologize that this is my third presentation for today, so I might be blabbling for whatever reason. So, okay, we're here to talk about gRPC. I'm very hyped about gRPC for certain scenarios. So who am I, first of all? My name is Irina Scurtu. I'm from Romania. I'm a software architect at a company called Endava. I also organize a user group. I teach .NET in my spare time, and I also blog. Not often as I would want to, but I also write there. So let's talk a bit about the monolith. Who loves monoliths? Because I definitely do love them. Because, well, life is easy for the developers. Everything is in there. You do not need to worry about things like, I don't know, orchestration, Kubernetes, or whatever. Is there. You have the code with everything self-contained, and is easy. Is bliss, in fact. So if we go a bit into the history part, we used to have applications like this. I think most of you worked with ASP, MVC, or maybe web forms. Why not? I know that I did. And still, it was a sort of monolith in there. But then things started to evolve, and we started to follow the trend and follow the hype and say, hey, we now have client apps written in whatever Angular framework or React framework or JavaScript-based framework. And we have an API. And because we have an API that serves data to that client app, we started to call them REST APIs, even though we had no reason to do that. But we're used to say, hey, I'm developing a REST API. Any junior developer that just touches the code says, I'm doing REST APIs. And that's it. But we're kind of doing anything but REST, because in fact, REST is hard. And we had the database and so on and so forth. But now, instead of managing one piece of code, we manage at least two. If we're having only one API and the client app and the database, of course. But now the future is super distributed. We need to follow the needs of our customers that need powerful processing power, and they need speed, and they need a lot of data served to them like right now. And we started to have something like this, a front end that comprises and gets together a lot of backends. And maybe those backends need to communicate with other backends, like server to server kind of communication. And we might end in something like this. We might have a .NET Core app that needs to communicate with a Go app, or .NET Core and a Node.js and whatever, third-party apps and Swift and whatnot. We need all these systems to talk with each other, to consume data and to pass data from one another. But, well, if you have .NET, how do you do that? You need to find some common ground. And usually when you have .NET with .NET, you have a NuGet package, you create HTTP clients, and you share those HTTP clients between your APIs, and everything is in there self-contained. But the problem with NuGet packages is that they tend to grow. They usually start as being something very small, maybe just the HTTP client with all the logic and retry policies in there. But soon they start to bubble and they start to grow with business logic. And you have client HTTP clients that have business logic in them. And they shouldn't have. They should be only the interface that help you call a different API from your server. And that's it. But, well, we have REST for everything, right? And usually those HTTP clients are meant to call REST APIs. But a client and a server, if you have only two of them, they do something that is called content negotiation. They talk about the format of the request, what is the payload, how is the payload formed, what is the content of it, how the error handling is done, retries, authentication stuff, and maybe when you have this kind of separation, what happens when the model changes, when the client needs something else from you, return from the server side, or maybe the server won't handle what data you send from the client side. So how do you handle these kind of changes, especially when you do not also own the client app? If you own the client app, then you're lucky enough to have, hey, you talk with your colleague and say, hey, I need that extra field because I need this UI stuff. And you chat with your team and you discuss and you negotiate the content of the apps, right? But that's kind of tedious. You always need to bother the UI developer to go there and say, hey, I need that stuff. Hey, see that I'm sending extra fields in the response, or the other way around. Not that I'm not encouraging team cooperation, I do, but what if we would find a way to manage all these changes, at least the server to server part, without bothering our colleagues? I mean, on the client side, it's easy. If you do not use some data or you have extra data sent over the wire, it's easy to handle. But what if you have a server to server communication and you have HTTP clients? You need to go in your HTTP client to modify the way you deserialize data and so on and so forth. It's tedious. Why should you do that? So then you might wonder, hey, still, what is wrong with REST? Why? Because it's de facto standard. Everyone uses, everyone goes to it. It has proven results. What if we are passing HTTP clients with specific DTOs in them? It works. But all this developer talks like, I'm going to use that and I'm going to use the other thing and so on. It takes time. And usually our customers and our business needs speed. And that speed is in terms of either development or the ways of handling things. And why not return back to the basics? Have you heard of RPC? Like remote procedure calls? I've heard of it and never used it, but in the classical way. And I also heard the Java guys that were talking about RMI and so on. But either way, RPC or remote procedure calls does nothing than is, I don't know, it's a concept from the 60s or something like that when the first computer programming started to appear. They realized that they needed the way of calling code that is in a different machine. And that's how RPC appeared. So RPC, if we were to look at this, it's a simple C# code. I will let you process it for a bit. It's nice, right? I mean, it's easy to read. You have a variable called order. You have a sales, whatever bounded context. I have a magnifier tool that, okay, here it is. So sales bounded context looks like something that it is injected somewhere, and then you call another method to create that order request. And then you have another call to process the payment. And then you check if the payment is successful, you arrange the shipping for that order. Easy, right? So the code seems like in the same context, in the same code base, right? It kind of looks like it, or at least there is nothing to tell you that is not belonging to the same code base. It's not in the same solution or in the same service or the same, I don't know, domain layer inside your app. Is there, looks like is all fitting together. But what gRPC does is to make the network, to hide a bit the network behind it. So for example, the first call to the payment status to see the process payment for the specific order makes a call over the network. And when you first look at the code, you kind of do not realize that you have a bounded context, you have something in there, but there is nothing to tell you that there will be a call over the wire. And this part in RPC will make the code look as if it were local. And when code look like this, it's prone to errors. I mean, at least with HTTP clients, you think that, okay, since I have an HTTP client, that HTTP client will do an HTTP request and get data from somewhere else or send data, why not? But with RPC, well, it's very easy to forget that you're calling something over the network because everything is looking so local. So the goal of gRPC is to make the network communication transparent. And when you have something transparent, you forget that it's there. So kind of the people behind RPC thought that, okay, what if we would have a distributed system that kind of behaves like a monolith because we love the monolith so much. So they invented RPC. I'm joking, but gRPC, it's something new. It's not the old thing, the old concept, but it relies on the old concept. A bit of a history, and I also thank Steve Gordon for that. In 2001, Google Stubby appeared. And 2005, gRPC has been open sourced. And in 2016, gRPC v1 showed up. And the rest is history because we're now today and talk about gRPC. So gRPC is something that is contract-based. You will have absolutely no code references when it comes to that code sharing part. It will use HTTP2 under the hood, which inherently is faster. And because it uses HTTP2, which is HTTP but upgraded, it is cool. And more than that, it uses a different serialization. It uses something that is called protobuf. And in the end, it results in a smaller payload. And if you think at it, you kind of transfer things over the wire, but those things that you transfer are smaller. And it kind of balances the thing. So it's also available in many languages and also does code generation for you, which is nice. So if we look at the proper and normal client-server communication, or server to server, I should have written server instead of client. You add something in the middle. You add a file, that contract, that is called a proto file. And this has a proper syntax. And in a way, it takes the place of NuGet package reference. So looking at the proto file, it kind of looks like this. So it's just a regular file with .proto extension. So in the end, you'll have some things to write in that file. You'll have the syntax. Proto 3 is the version of the proto language. You'll have an option to name your C# namespace. And in this case, it's named my first gRPC. And the package that it will be generated. You see, it's not C#ish, is more other language oriented package. But it's just a specification language that is, and it's also similar to C#. And what you're doing here is to define the service that you want to expose. So by defining the service, you're basically telling to the outside world what are the options available. So in our case, you have a method called compute Fibonacci that has the parameters and returns a Fibonacci result. That's the definition. It's like an interface where you specify, hey, I have this method that you need to give implementation to. And the two types that are used, it's simply defined with the keyword message, and then the name. And then you have, let's call them properties. The deal is that if you see here something like one, that is not a value assignment. That's the order inside that object because it uses binary. So if you would have another field, that field will have equal to. Okay, so that's not a value assignment. So the same happens with the last type. Okay, so what you say here, that your service uses this, sorry about that, uses this and returns this kind of object. And kind of that's it. Okay, now, once you know this, that you need to define your service schema, you have 4 options. You have a method or modes or types. It depends totally on who you're listening to. So methods, 4 ways of using gRPC basically. So you have the unary, which is kind of request response. You have server streaming, client streaming, and guess what? Bidirectional streaming. So you have 4 options of using gRPC. The first of it is unary, or super easy, super known because it's super similar to request and response, but they call it unary, is when a client makes a request to a server and the server responds with only one response. To define such operation, you will need to write something like this inside your service definition. So what you accept and what you return, okay? The next piece is server streaming. Server streaming is somehow similar because someone issues a request but expects back multiple responses. So it kind of looks like this. They send multiple pieces as part of the bigger response. It's not one-to-one, it's one request, several responses. The third option is, guess what? In reverse, is when a client sends many requests, for example, and gets only one response back. One and several things as part of that request and receives one thing back. Another part, or bidirectional streaming, it's a combination of the previous 2. So a client sends many things and a server responds with many things. So how do you define in your server which is which and what operation you are using? Is very easy. You just go in your service and inside the method that you want to expose, you just add the stream keyword where you would like to, if this is as input, it's clearly that is client sending more as a stream. And if you have only on this part as part of the response, it's clear that the server is pushing several responses back. And if you have both the client sends several requests and both the server responds with many parts of the response. Okay, so I do not know if we should look at the code. We should look at the code. So let's see. I have here a small demo, and I will show you that with a little bit of zoom. So I have a service that is simply a new project. And when you select a new project, you'll have a gRPC service, and it comes ready with a few things. So you needed to select the name and everything. And inside it, hopefully it won't close my current project. In .NET 5, you'll be able to select an ASP core gRPC service. We'll create this to see how it looks in terms of what it contains. So what's different is that you won't have any controllers, anything. You'll simply have a folder called protos, where you'll have something that is default in terms of what we know in weather services now when we're creating APIs. It's a proto with that syntax. And what it has, it's a service called greeter that defines a method that is unary because we do not see that stream keyword in front or at the return part. And on top of it, we have something that uses this proto file called greeter service. And it does nothing else than to inherit my Visual Studio. It's running nuts right now because it's showing this as not being a class or whatever. Basically, greeter base, it's something that is created by default by Visual Studio. That's why I told you that we have code generation. It's building now, so we're going to wait for a bit. And what you do in this service is to implement what you specify in the proto file. So you had say hello that returns hello, receives a hello request and returns a hello reply. And this is what you need to give an implementation for. So in the greeter service, you'll see you have say hello as a name. The first parameter is the request as a comparison. And the second parameter is the server call context, where you'll be able to extract what you sent and what you receive basically from the calls to the gRPC. And what you do is just to reply with this type that you specified. And in this case, it's called hello reply. And the hello reply is exactly this. And think about these types as being simply, I don't know, C# objects, because they have properties and these properties can be accessed. For example, here, it's hello reply and it has message. And you can assign and you can do things with it. Cool. This is the basic of a gRPC creation. I'm going to close this. And I'm going to show you, of course, my Visual Studio closed. Why not? I'm going to open again the project. Okay. So if we were to think about when we have an API and another API that need to call each other, we usually added right click and added the project reference. But looking here, we kind of do not have references to other projects. We have this proto file where on the same example, I use the same patterns, the same message types, and I also have the other 3 types. But if you were to look at different projects in this demo, you'll see that I have nothing that is referencing to the server. I have no package. I have the Google Protobuf and the gRPC and gRPC tools that are needed in order for you to work with gRPC, but there is no additional reference. So let's have a look to see the first example. So let's look a bit at the server, the implementation. So here, apparently it works just fine because the greeter shows everything. The service is the one that once you inherit from the code that is generated by Visual Studio for you, you can provide implementation. And the first thing that you can see is the same code that I showed you before, called say hello, receives a hello request and responds with a hello reply. That's it. So these are the methods that you're willing to call. So this is my, let's say it, API. Okay, I'm gonna run this in the console just to show you how it works. So I have 4 methods exposed in here, which I'm gonna call from different console apps. Okay, so we're gonna see here that is listening, everything is just fine. And now the first thing that I want to show you is the Unary console app. And we're gonna look at the program. Now with the server running, we can do like this. We can look, and there is this concept of a channel. If you look at it and compare it to HTTP clients, it's kind of similar, right? Because you have the type and you say, hey, I need a new of this, and you specify the address, maybe give it a few options, and then that's it. You can call, you can use that channel. But more than that, in order to make a gRPC request, you need to instantiate a client, and that client is there for you to use. You also you only need to pass it a channel. You need to tell it where to call. And localhost 5000 is exactly the server that is listening. So from this console app, we're going to call the server. Okay, so how do we call the server? As you see, I have no reference in here to my server. No way, nothing else, nothing more. It's just a console app. And what we can do is to create a hello request. Give it a name. Let's say Zurich. Oops, not there. Apparently it doesn't want to write. Okay. And then from the client, you'll see that I have available all the methods that I'm exposing, bidirectional client stream and so on, and server stream, and a few other things, but we're talking only about the 4 of those. I'm writing the name that I'm sending, what I do, and I'm waiting for a reply. Okay. Here we have a few options, but you can also call the method without these call options. In the call options, you can specify things like a sort of timeout or how many times, or you can pass it cancellation token source to make sure that you're not crossing the limit and waiting for a reply and so on. And I'm going to open another console, which is exactly this, the Unary app. And one to the left and one to the right. And I'm going to .NET run it to see what's happening. Hopefully it works. Okay. So I logged here that I'm sending Zurich as a parameter, and I got back, hello, Zurich. So it's a basic request response, right? And also in the server side, you'll notice a few informations like request finished with HTTP, and the verb uses post because you sent something. This is the method. As you see, it's not an API, it's more of an API combination with code path. It's like greeter, say hello. And the MIME type that is used is application gRPC. And also you have a status callback. And also you have the time of the request. Okay, looking back into the Unary project. So it's easy. I'm calling greeter client. I'm making what I need to create the request, and kind of that's it. And I think you might wonder, okay, but since I have this, API is running, but I have no web, how is it done? Well, how's the reference? How do you know something like this? How do you know how Visual Studio knows, or the framework knows, what are the available options? Bidirectional, client stream, and so on. Well, let me show you something. If you open the Unary CS proj, you'll see there that I added something called an item group. I hope this is better. I added something that is called protobuf. You include the path to that protobuf file, and you said that, hey, you need to add a property in this XML-ish stuff called, hey, this is a client. This is the gRPC client. And also, you'll notice that I had a path that is not under this file, it's actually the path to that proto file, read proto. So if we navigate further, this path can also be something that is external to our application, can be a location somewhere on the drive, as long as all your applications have access to the same proto file, everything is in there. So I'm gonna try and see if I find this. So open folder and file explorer. So I'm here in the Unary project. I have bin, object, and that's it. If I go up one level, you'll see that I do not have Protos files. I do not have it. And it should be in here. Protos, up one level, down one level. So I referenced the server proto file, but also this can be done at this level. And this way, all the applications will have access to it. Think about how powerful can this be when you're using a CI/CD tool and you're using everything in command line and you're specifying and you're moving these proto files. You don't need code sharing in order to be able to call something. You just need to change one path so that this application can have access to that path. So if you look back at this proto file where it is, it will call this. So we call this, we got back a reply. So this proto file is the interface, is the interface definition, service definition language, basically. You're saying, okay, if you're using this proto file or this several proto files, you'll be able to access these operations. I'm just talking myself, but I'm going to ask you at the end. WCF, anyone? Familiar? But I think it's way powerful. I mean, you're not adding any reference, but kind of the principle is the same. Okay, so I show you the Unary part. Okay, so sending hello and sending hello back. Cool. Finish with the Unary. Let's look at something else. The server is up and running yet. I'm going to stop it for a bit. I'm going to clear the screen and I'm going to start it again. And I'm going to show you the client streaming. Let's see. So the server is listening and the client streaming should write nothing. So the client to the right-hand side waits for a response. And it waits because I do not remember what I added in there. 1,000, 10,000, but we wait for a bit. You see? So the server got several requests, which means that the client sent several chunks of data, several requests, independent requests. And what it got in turn as a response, it was the last of these. And it also shows you how many time. Wow. How long it took in order to finish it. Okay, so several things in, one thing out. And let's look at the code. So this is the client streaming. And on the client streaming is the same principle. The CS proj for the proto file is edited. You instantiate the client because once you were creating your proto file and building the app, and this console app has access to that location, it will generate this for you. And what I'm doing in here, why you saw so many requests, is to call the client stream a method that I expose in the proto files. I'm creating a for. I know it's a dummy example, but I think it proved the purpose. And from that call, I read and read the request stream. I'm reading what is, I'm writing in the write stream, sorry. So I'm writing async, several instantiating I by I, one by one, a new hello request. And what I do at the end is waiting for that response. I know that the syntax is maybe not so familiar, but it does the job. So you basically calling the method that you want from the proto file, from the service that you implemented, creating a for, and in order to send something in the request string, because here you're sending several things in the request one by one, you need to write in the request stream. So that's why you're using this. And at the end, you wait to send everything. And at the end, you know that you're, one thing that is very cool is that once you can use var, why not? But you also can use the strongly typedness of it. It will recognize. I mean, he knows that you have this type and you expect a hello reply back. And what I did is simply to write back to the console. Cool. This is client streaming. Let's close this out because it's done. And our server is still up. And I'm going to show you the server streaming. And fingers crossed. So the server now, once the request is initiated from the client, it streams back with tons of eyes. It's the same principle, increase in a for an I in a loop. Okay, so the code for it's not very different. I have a bad naming in there. That's why I didn't want you to stay too long on it. So the server streaming is not too different. It's the same. You create a new channel, you instantiate your client and passing it the channel, and you send. Sorry, yeah, I'm here. Okay, I'm okay. And instead of client, you're calling the last method server stream, and you give it a hello request and add a few things in there, and then you wait the replies. And in the replies, you're basically reading for the response stream. You're, in the previous example, you were writing in the request stream. Now you are reading from the response stream. Okay. It's the same. You wait everything that it's basically sent in there. And in the server stream, I will show you what happens in the service. Okay, server stream. It's here. Same. An I, a loop that goes to this value and sends a hello reply and sends only responses and replies. And you write in the response stream. Okay, so basically calling this method, you only need to read what you're getting. And bidirectional, it's doing both in the same time. Server is there, but you see this moved, showed you what method was called, is greater bidirectional. And basically what I did here is to send the same in the loop 10 items and receive those items back. So both ways communication. Okay, so how it looks is simply creating a message bidirectional. Hello request, this is an iStream reader in the service, and it's iServer stream writer for the reply. These are two different types that differentiate the two types of, this is the stream reader, stream writer. Okay, and here you have the ability of accessing the current context by using the last parameter that you need to have there in any case, server call context. And from the context, you can access the current. It's like using HTTP context current in Web API or MVC. Okay, what you did here is like taking each item that you're receiving and creating a new message with the payload and writing it back. this is basically the scenario. Okay, so the same in bidirectional. Okay, in the program, things are getting even weirder. So this is the separate project that show you both. Same client, the channel, pass the channel to the client. You can have a cancellation token source. And in a using is not the clearest thing possible, but you create tasks. And while you can read from the response stream, you can do these kind of things. Same 10 messages you're writing in the request, and then you will wait for them. It's a strange syntax, but you can also find it in the Microsoft documentation for it. Once you pass this strangely looking code, and you understand the gRPC context, what it does, and how you can handle this, imagine that you have bidirectional communication without using any other, I don't know, additional tools like Signal or whatever. It's there for you to use. Behind the scenes, they're using, I think, something on top of WebSockets or something like that. Okay, so I think it's best to go back to the proto file just as a summary. So when you specify a method as being, I get this in and I return that out, is unary. When you define a method that has this in, but for the out, you add the keyword stream. This means that it will stream the response. It's sending several responses. Same, it happens when you add the stream keyword as a parameter. You say, hey, I have this, I received this in a stream of this type, and I return this. So many in, one out. And for the bidirectional, you have stream keyword in both places. And it means that I received many things in and I send many things out. Okay, so having this definition, you can go to your service and give an actual implementation for it. And you'll see all of these are overrides because I wanted to use tasks and I had to override what is specified in there. But depending on the context, you'll have simple, you'll have the in type and the server call context as a parameter by default for the unary. For the server stream, you'll have the things in simply for without the stream keyword. And as the second parameter, you'll have an iStream writer of your type that you're sending. And of course, the third parameter that you cannot get rid of, that gives you, allows you context access in a way. Okay, for the client, when you have that stream keyword in front here, you will have async stream reader, like reading the in things. And for the bidirectional, it's a combination of those two. You have async and also you have server call context. What you do inside, it's basically your job to implement the business needs inside these methods. What you need to understand basically are what means client stream, server stream, bidirectional, and when are the right user scenario for those. Another cool part is that I do not have a code reference that I'll have to maintain for my project basically. And if I want to, I can go in here to say, hey, I do not want to expose this, and I'm gonna build this, and it's gonna break because I have something in the project that, and I also think I need to stop the server. And I also I have something else started. No, that's it. Two project failed. So since I commented the bidirectional, I need to go to the bidirectional and I'll see that, hey, this is not visible anymore. because all the changes on build are propagated down the line on anything that is using that proto file. And since I modified the file, this won't be available because I commented out as like deleted it. So bidirectional streaming won't be there. So it won't be visible. Once I go there and put it back, I will have everything working, hopefully. 5 projects succeeded, which it means that yay, works. And now it is visible in here. So what it happens is that from that proto file, you'll get something like this, and I will F12 into it. This is a C# class that you're not seeing in the project. It's not there, like for you to modify, but it contains what you specified in the proto file and in that service. It's strangely looking. You'll have the service name that you gave. It has a few things about serialization and using protobuf and so on. A lot of things. Methods that you're exposing. Unary says like this, server streaming, how it looks, how it's called, and so on. A Gritter client is generated by default for you because I didn't write anywhere something like create a Gritter client, but it's there for you. And again, it's strange looking and so on. And your virtual methods and so on. So it's there, generated by for you once you modify the proto file. So coming back to the slides, what are the strengths of gRPC compared to REST? And why and when should we use this? So REST is more resource focused and embraces pretty much everything in HTTP semantics. It gives you loose coupling-ish. It depends what you understand by loose coupling, because when you share code, whether NuGet packages or not, when you change that code, you introduce breaking changes. It's text-based. And RPC or gRPC, on the other hand, it's action-based. It's developer-oriented. It embraces programming semantics. It has a tighter coupling in a way, and also it's binary-based. And when I say it has a tighter coupling in a way, is trying to say that still you will have to have the API that receives gRPC calls up and running. You kind of have the same problems as in REST. Is maybe friendlier somehow, but I think it's worth for its performance. REST versus gRPC is kind of 8-ish% smaller, the payload for the same thing compared to JSON payload versus binary. It also allows you to have polyglot environments because that proto file is universal. We just received the code generation in C#, but now by using that proto file, you can communicate with, I don't know, for example, Dart or Go or whatever languages. And you can consume and call code from other languages by using the proto file. So the common ground between all the languages, C++ or whatever, is that, the proto file. Also, it's super lightweight and it's useful for point-to-point communication. That contract-based approach, I think, is very nice, but you also need to learn a bit how to write in the proto syntax. It uses HTTP2 in summary, and also it supports different streaming types. And we cannot talk about the tool or technology without also looking at its downsides. And a downside would be that you'll still have temporal coupling. Now you're not sharing code per se, but you'll have the same temporal coupling. If service A needs to communicate with service B, then service B needs to be up. And that's kind of the temporal coupling. And another maybe downside, from my opinion, is that you might forget that there is a network involved. Well, it looks so nice in terms of code. I mean, hey, I'm having a client, I'm calling the whatever methods in there, and woof, voila, it works. But in fact, you're you're calling and doing calls, HTTP calls over the network, and it's not obvious. Another downside would be that it's not human readable, and you'll need better testing, and you'll also need to focus on CI/CD. I mean, think about it. When something happened, when you had the package referenced in your code, and something changed in that package, you had a version of that package, and now you have a protofile where if three apps access the same protofile, when the protofile changes, well, all the apps will break. So you kind of need to take care of that, to be focused and to have better testing and in whatever CI/CD if you are using one, but you need to take care of that. So in summary, it's great for microservice communication, in my opinion. But you also need to keep in mind that you're doing network calls in there, even if it looks like you're calling just simple methods. And also, one thing that I think is cool is that it removes the need of nugget package sharing. I've seen, I don't know, spaghetti of nugget packages, or I don't know, spaghetti is an understatement, because they started small and they ended up with having a mess. They put everything in there and that had the reference to the other side and so on and so forth. And it wasn't nice to untangle everything. And I think also the future of web APIs, even though Microsoft and the community is doing a lot of efforts in, I don't know, integrating the things that we're using day by day and so on, there will be no more hunting of documentation. I mean, if it's in code, you can explore that code in a way. You won't need to look at whatever, I don't know. You remember the WSDL files from SOAP? Weren't nice, but you still needed to look at those. And there will be no misinterpretation of status codes. Yay for that. Because from 63 of them, I think we're currently using maybe 10 and extensively. And also there will be no more data parsing errors or miscommunication and mishaps in code and in Teams when someone removes a field and breaks something in there in another app or God knows where. So I think also distributed systems, I like to say this, are all about trade-offs. We need to know and be aware of every technology that is out there in order to discern better what to use. We shouldn't chase the newest and brightest and shiniest technologies out there if we do not have the right case for it. And as next steps, you can have a look at gRPC web, a bit of HTTP2, and add the protocol buffers and the syntax in there. And there's something that I didn't mention, but I really want you to show this. I had here a line that's saying found some trailer values called gRPC header. In gRPC, you can also have headers. And they are not calling them headers, they call them trailers. Let me show you this. Bidirectional, here it is. Okay, I'm just gonna do this and show you because, okay, here it is. Server streaming, anyways. So there is a way for you to add something in the header of that call. It's basically a dictionary, and they allow you to call a method that is called getTrailers to give you the dictionary collection, the collection of key value pairs. So you kind of can mimic. You can use this. So it's metadata entry, my header, and you can add the name and the value for it, and you can add it when that request is made. So it's another way of mimicking a classical HTTP header, just it has a different naming because the context is different. Really wanted to show you that. Okay, so thank you for listening, and thank you for having me. I look forward for the beer there. there the guys were talking before. Come on.
Yeah, it's bring your own device. No, own beer. Bring your own beer.
Yeah.
Cool. So if that is a who
Where
has
is
the
that music coming
yeah
from?
It's my music. So it's not my music. My wife is doing Zumba online.
oh
So basically, because in Switzerland we cannot go to like Zumba trainings anymore, so we have to do it at home.
okay, sounds pretty cool.
It's in
So-
between kids running.
Ooh. Dodging skills, that seems like a bit of effort.
So let's see if we have questions. Oh, we have questions. I forgot
Yes,
to look at
we
the
do.
Slido.
Yeah.
You want to read, or I can read them for you?
I think I can read them, but
Okay.
I also need to have Michael mute himself. Not that I'm not enjoying the music.
Otherwise, we will start dancing.
Or maybe I will start dancing. So I do not want that. Okay. So the first question is, since .NET gRPC doesn't have controller, how would we be doing action filters and middlewares? That's a very good question. You can have, I didn't look into it. I just stumbled upon a thing. You have that when you do calls. So you're basically accessing the context of the calls. Let me see. I think it's better to share my screen just to show you what I'm talking about. So when you're defining your service, you have this third parameter called server call context. And in that, you can access the current context. And I guess there's the place where you can access what's in the call and you can filter there. But when you have action filters and middlewares, I don't think there is that concept of action filters. Middlewares, okay, you can do them, but filters, because you're basically calling code. If you need a different parameter, then you can, I don't create another method. You're not limited only to the four that I'm think about. I don't know, gRPC service as a simple class. You have methods, you have behaviors, you have properties, you have types in there. So it's the same approach. It's a bit of a change of an approach. I hope I answered the question. The second question is, can we be hopeful to have any swagger for gRPC to improve testing while development and to be able to share along with the front-end team or client? That's a very interesting question, but I really think that the proto file, this is your documentation. This is what you have available. It looks different to testers. It is different, but these proto files, I mean, it specifies what you have access to. Okay, you have this, receiving this, and this looks like this. So I really don't think that we will have something swaggerish like, because the concept is different. That's my opinion. You can throw tomatoes, but this is what I believe. Next question is, do you or anyone have experience with protobuf.NET gRPC, which does gRPC but based on .NET interface contracts similar to WCF instead of an abstract base class? I don't think I really grasp the question in here, because the interface contract similar to WCF. If you're referring to that WASL stuff that exposes the operation and so on, I do not have experience with it. Again, the protobuf file says what you have in there. Another question. I work for a company organized on small squads, so we can't rely instant switch to gRPC. Is there any way we can expose the gRPC methods and also REST HTTP? Ooh, very good question. I think at first thought, I think the only way of doing this is to support both, and to support both, you'll have to have your REST, and alongside you'll need to create the proto file and the greeter service. It's like having, okay, you have this server with proto files and with services, but nothing stops you to have, okay, add new folder, controller, and so on, because this is sim controllers and other controllers. So nothing stops you to do that, because behind the scenes, this project, even though it seems special, is just a .NET Console app. It has the startup, it has the programs and app settings and so on. Just it doesn't have the controller part, but the rest you can do it. And also, why not? You can call in your controller if you really want to do that. You can call the gRPC service in front, exactly like I am doing here in the console. But what you obtain there is you're doing a hop to your controller, and from your controller to the endpoint. So it's not cool. You have 2 calls instead of 1. But I think you can think about something. Next question. gRPC and SignalR seem to overlap quite a lot in terms of features. Besides the code decoupling advantage, in which case would you choose one or the other? I think you're referring only to the bidirectional part if you're mentioning SignalR. I think there is a context that we need to kind of look at in terms of SignalR talks, okay, server to client, but that client is a browser or client app in front-end app. And in gRPC, we kind of have server to another server, in which case one of the server is the client of the other. So that's the context that I think. So I would use gRPC for server-to-server communication, and maybe SignalR for client-to-server communication. The next question. May we know your opinion during server-server communication? How well does it perform compared to WCF TCP versus HTTP2 gRPC? Just a thought on this. So HTTP2 has a different way. That's why I added that as a reference at the end of my slides. Has a different way of handling data. It's way faster. I cannot tell you, since I do not know it all, about how it actually works, but its performance is the newest version, and it's always recommended to use the newest version. WCF is there. It will be there in a lot of projects, but for sure, hopefully, a lot of folks will start to get rid of WCF. It works well on HTTP1. It works better in HTTP2. How well? Well, I think it's a super subjective response. How well? Well, it depends on the tools, because we always want faster and newer tools to gain a lot of things. And HTTP2 is faster. They're currently working on HTTP3. So I think we should start to switch on HTTP2 just to catch up. And the binary serialization is way better compared to WCF, because it has newer algorithms and so on and so forth. So that's my take on that. The next question, Bart asks, what about circuit breaker retry pattern? Are there libraries for this already? Not to my knowledge, to be honest, but I think Poly works, because I didn't try, but in RPC, you can catch exceptions, for example, and that exception in gRPC is RPC exception. So whatever exception it happens gRPC, you get an RPC exception, but you can treat them separately on this kind of status codes that are specific to gRPC. For example, you do not have the classical, okay, for and so on, but you have something like thread aborted, already exists, cancel, data lost, blah, blah, blah. Okay, and out of range. It's a handful of them, but you can use them. And depending on what is the specific scenario you have, you can treat them. And it's an exception. So Poly, I think it doesn't answer only to the HTTP clients requests. I think it can be used, or at least you can give it a try. But something specific for, I do not know of. What terminal am I using? It's called Commander. Commander, CMDR. I use it for a long time. I tried to switch to Windows Terminal, but I don't know why. I simply can't for the moment. So you can, it's a zip file that you download, and it has a lot of things. You can rename tabs, you can create and save stuff. It's pretty cool.
Awesome. There was a lot of questions, but you mastered them well. It was a great talk. I think everybody enjoyed it.
Oh, thank you. I'm blushing, but you're not seeing right now. So thank you everyone for listening to me. I hope you found and learned a few things.
It was really cool, Irina. Very well delivered, and you managed to respond to all the questions. Some of them were a bit tricky. So I activated the volume so you can enable your microphones. Please do so. Perfect. And now, thank you, Irina, and everybody, please join me.
I feel like at in-person conference.
Really? That's the idea. It's perfect. So now we will stop the live streaming. So I will stop it right now. I hope I didn't break it this time. And we will do a